Good morning, students. Welcome to the class in physical science on the topic measurement. It is a very important concept that you have to be strong in. I would like to start the class with a lovely quotation by scientist Grace Hopper. One accurate measurement is worth 1,000 expert opinions. Yes, this quotation highlights the importance of accuracy in measurement, especially in physics. It is all about measurement, and science is, of course, verifying experiments by taking accurate measurements and expressing them with proper units. So, hope you know the importance of measuring and expressing them with proper SI units. So, we also deal with quantities of measuring things in our everyday life. So when you go to a cloth merchant, you buy cloth, you have to specify the correct quantity of cloth that you need to stitch a dress. And when you go to a vegetable vendor, you have to specify the quantity of vegetables that you need to procure. And when you work in labs, it is very important that you measure and express them properly. So the quantities that you measure directly or indirectly are called physical quantities. So we measure length, mass, time. We also measure and calculate area. We find out volume of various containers, capacities, and those are called physical quantities. So the quantities in terms of which you can express the laws of physics are called physical quantities. You can measure them and you can express the laws of physics through them. So how will you define a physical quantity? Quantities in terms of which laws of physics can be expressed and which can be measured directly or indirectly. So length, mass, time, area, volume are the physical quantities that you can measure and through which you can express the laws of physics. Now in this image, in this slide, you see a lot of images. I have also specified the quantities that I have specified with proper units. So here I have expressed 1 second and here it is 1 kg. The currency it denotes rupees 2750 and here you have a scale, a measuring device to measure length. So can you just tell me which one of these is not a physical quantity? So now you just recall the previous slide where you have the definition of physical quantity. So quantities in terms of which laws of physics can be expressed and which can be measured directly. Quantity which you can measure directly and also through which you can express the laws of physics. Now you just tell me which one is not a physical quantity? Yes, it is the currencies because you cannot express any laws of physics using this. Though you have a value, the denomination with the proper unit, you cannot express physics laws using this. So this is not a physical quantity, whereas the others are the physical quantities. You can measure the length, you can measure the time, you can measure the mass. All these are the physical quantities through which you can express the laws of physics, whereas the currency is not a physical quantity. So any physical quantity that you measure has two parts. The first part is a magnitude and the second part is a unit. So when you measure the length and you express it as pi meter, phi is the magnitude or the value and meter is the unit. So 5 times the 1 meter. And when you write mass of an object as 40 kg, it has got two parts. The first part 40 is the magnitude or the value and the second part is a unit. Kg is a SI unit of mass and time we express with the SI unit second and 2s, that is 2 second. 2 is the magnitude and s is the unit and area is 20 meter square where here 20 is the magnitude and meter square is the unit. So a physical quantity always has two parts. The first part is the magnitude and the second part is the unit. So we already know, we have learned in our 6th standard that physical quantities are classified as fundamental quantities or base quantities and derived quantities. So we classify the physical quantities as fundamental quantities and derived quantities. So what are fundamental? They are the basic quantities which cannot be expressed in terms of other quantities like length, mass and time. So you don't need any formula to express those quantities. You just measure and write with a proper unit. So the quantities which cannot be expressed in terms of any other physical quantities are called fundamental quantities, whereas the derived quantities are derived from the basic or the fundamental quantities. They are obtained by multiplying or dividing these fundamental quantities. So area, volume, density are the derived quantities which are obtained by multiplying, dividing these fundamental quantities. So what are derived quantities? They are obtained by multiplying, dividing or mathematically combining the fundamental quantities. For example, area, volume and density. So now we have already learnt in our 6th standard the 7 fundamental units which you have to be thorough with. So these are the fundamental quantities, 7 basic quantities, and these are the SI units of those 7 fundamental quantities and their symbols. If you are thorough with these fundamental quantities and their units, you can easily derive the units of the derived quantities like volume and density. So let us recall. Length, the SI unit is meter, the symbol is m. Mass, the SI unit is kilogram, the symbol is kg. Time, second, SI unit is second, and symbol is S. Temperature, Kelvin, SI unit is Kelvin, symbol is K. Electric current, ampere. Just note down, the symbol should be represented with capital here. Here again it is capital K, whereas the others are small letters. So when you are writing the symbol of a scientist, symbol named after a scientist should be denoted with a capital K, capital A here, whereas here when you are writing as a unit, as a full name as Kelvin, you should use small letters. So electric current is represented with the SI unit, they are expressed in SI units ampere, and the symbol is capital A. Luminous intensity or brightness, the SI unit is candela, the symbol is CD, amount of substance is mole, MOL. So these are the 7 fundamental quantities, fundamental units and their symbols which you have to be very thorough with, so that you will not go wrong when you are deriving the units of derived quantities. So what are derived quantities? Once again we will recall the quantities, the physical quantities which can be obtained by multiplying, dividing or by mathematically combining the fundamental quantities. Example, they are area, volume, density. So what are derived units? The unit with which these derived quantities are expressed. For example, area is expressed in meter square, the SI unit of area is meter square, volume is expressed in meter cube, and density can be expressed in kilogram per meter cube. So you will be learning in the next part of the lessons. So what are derived quantities? The quantities which are obtained by mathematically combining the fundamental quantities are called derived quantities. They are area, volume, density, and the units in which these derived quantities are expressed are called derived units. Now let us consider the derived quantity area. Area is not a fundamental quantity. You derive it by using a formula, so which we are going to deal now. So what is area? How will you define area? Area is defined as a space occupied by a flat surface, flat shape, the surface of an object, of a table, of a book, of anything. So the flat plane surface area. So what is the SI unit of it? It is meter square. So area is the space occupied by a flat surface. Now let us consider an example of a rectangular plot of length 10 meter and breadth 3 meter. So now let us learn how to derive the unit of derived quantity area. So we know this is a rectangle and we know what is area is the space occupied by this flat surface. So we are going to see how much of this length is extended up to, that is 10 meter into 3 meter will give you the area of this rectangular land. So area of the given plot which you have already learned, L into B, that is length into breadth. So length is 10 meter into its breadth 3 meter. So 10 into 3 is 30, whereas meter into meter is meter square, that is meter to the power of 2 is written as m square. We say it as m square, which can also be written as square meter. So 30 meter square can also be written as 30 square meter. The square is not going to represent the shape of this land. It is just to represent this power 2. So we can write it as 30 meter square or square meter. Now let us consider another example where you have a square piece of land or a square table whose surface has side 1 meter. So since it is a square, the sides are all equal. So we have 1 meter as one side, the other side is also 1 meter. So the area of the given square is side into side. So it is 1 meter into 1 meter. So 1 into 1 is 1 and not 2. So many of you will go wrong here. So 1 into 1 is 1 and meter into meter is meter square, which can also be written as square meter. So it's just quite simple. So if you do it with little carefulness, you can just rock. Thank you.